We're going to be talking today about the properties of secants and tangents. In the first example, we have two secants that are intersecting outside of the circle. So the rule that goes with those is this. You're always going to think of it as the whole segment times the outside equal to the other segment, the whole times the outside. Now, I had a friend of mine tell me that he remembers it by saying, whoa, whoa, whole times outside, whole times outside. Whatever works for you. We want you to remember it. So in this problem, it would be the whole thing, which is C, times the outside piece, which is A, equal to the whole thing, D, times the outside portion, which is B. So in some cases, you just have to remember to get the whole thing, you're going to add these two parts together, just segment addition. So let's take a look at our two examples. In our first example, take the top segment, the whole thing is 16, and the outside part is 6. The bottom segment, we have x and then we have 4. So to get the whole thing, please don't say 4x, it's x plus 4. You have to add those two pieces together times the outside piece, which is the 4. So the outside part times the whole thing. And now we just solve. So 16 times 6 should be 96 equals, and we'll do the distributive property, 4x plus 16. And then I'm just going to grab my calculator and solve it. And I get x equals 20. Now I'm going to go check this. I'm going to see if 6 times 16 equals the same thing as 4 times 24. So I know that 6 times 16 is 96. 4 times 24, also 96. So 20 is the correct answer. Let's take a look at the second one. Again, we want the whole thing, which in this problem is x plus 8, times the outside. So x times x plus 8. On the bottom segment, we want the whole thing, which happens to be 16. We're going to add those pieces together, times the outside part, which was 3. So when we do our distributive property here, we end up with x squared plus 8x equals 48. We have a quadratic, so that's going to require us to make it equal 0 and then factor. So let's do that. X squared plus 8x minus 48 equals 0. I need factors of negative 48 that are going to add up to 8. So if those are not fresh in your mind, there is a way to use your calculator to find them, or I just like to start listing them until something comes to me. I could use the 4 and the 12. I could use a positive 12 and a negative 4, and that's going to give me the positive 8x out of factors of negative 48. So this one, x is negative 12 or x is 4. So let's plug them in and check. So if I plug in negative 12 right here for x, can that segment length be negative 12? No. So we're not going to use negative 12. Let's plug in 4. So now this segment here says 4 on the outside times the whole thing, which is 12. That equals 48. And that's exactly what we got for the bottom when we said 3 times 16. So 4 is the correct answer, and we double checked it to make sure. So be sure to check, negative 12 didn't fail because it was negative. It failed because we plugged it in and it created a negative segment length, and that's not allowed. All right, let's apply this property to when a secant and a tangent intersect. Now we already know what happens if two tangents intersect, then their segments would be congruent. But if a secant and a tangent intersect, it's going to be the same rule we just did. The whoa-whoa, whole times outside, whole times outside. The difference is, we'll see here in just a second, This secant right here, the whole thing was C, the outside part was A, and then we look at this tangent segment. Well, how long is the entire segment? It's B. How long is the outside part of the segment? Still B. So we're still doing the whole thing times the outside. It's just that with our tangent segment, the whole thing is the outside. So it becomes B squared. So there's a few ways this could show up in our problems. So let's take a look. The first one, we got our secant and our tangent. So our secant has the whole thing is 9, the outside is 4. The whole thing times the outside, and this is my tangent where the whole thing is the outside, so it's squared. So if 36 equals x squared, we take the square root of both sides. And I know we talked about this a little bit before. I would get negative 6 and positive 6, but then look at x. That can't be a negative value because that would give me a negative segment length. So we're going to take the 6 because a negative 6 wouldn't work in this problem. Alrighty, let's do this one and then we'll go back to the top one. So take a look at this one on the bottom. We again have our whole segment, which is x plus 4, and then we have our tangent line. So we're going to say the whole segment times the outside piece, 4 times x plus 4, and since my tangent is my outside piece, I do x squared. So now 4x plus 16 equals 64, and we solve for x. 64 minus 16 is 48, so x is 12. And again, we can double check that. 4 times 16 really does equal 8 times 8. Alright, now let's tackle this top one, which is going to be a little bit different than the others because of the location of my unknown. So this top segment, the whole thing is going to be x plus 15. Please be sure to add your two pieces together, not multiplying. So then I do my outside part, x, times my whole thing, x plus 15. And then over here, 10 times 10 is 100. Do you see what's going to happen? It's a quadratic, just like we had on the last section. So x squared plus 15x equals 100. So I'm going to subtract the 100 from both sides and find factors of negative 100 that add up to 15. And again, if those don't pop into your head, you could just start listing. 1 times 100, 2 times 50, how was that? 4 times 25, 5 times 20, and I think that's it. So I'm going to write x plus 20, x minus 5 equals 0, and that gives me my two answers of x could be negative 20 or x could be 5. So if I look back at my original problem, can x really be negative 20? That's a segment length, so no it can't, but x can be 5. So if I put in 5, I get 5 times 20 is 100, and 10 times 10 is 100. So just be careful when you end up with one of your x squareds that you use the proper process to solve, and make sure to exclude answers that create a negative segment length. Off to practice.